Commenting on the skewness of a dataset. Skewness refers to the asymmetry of the distribution of values in a dataset, and it provides insights into the nature of the data. In this study guide, we will explore what skewness is, how to calculate it, and how to comment on the skewness of a dataset effectively. What is skewness? Skewness quantifies the degree of asymmetry of a distribution around its mean. A dataset can be classified as positively skewed, when the tail on the right side of the distribution is longer or fatter than the left side. In this case, the mean is typically greater than the median. Negatively skewed, when the tail on the left side is longer or fatter than the right side. Here, the mean is usually less than the median. Symmetrical, when the distribution is balanced and the mean and median are approximately equal. Understanding the skewness is crucial because it affects various statistical analyses, including regression, hypothesis testing, and the calculation of confidence intervals. How to calculate skewness. Calculating skewness can be done using several methods, but one common formula is Pearson's first coefficient of skewness. Basically, in this formula the skewness is determined by dividing the product of 3 and the difference between mean and median by standard division of the dataset. Example calculation. Let's consider a small dataset, 2, 3, 3, 4, 5, 7, 8, 9, 10, 10, 12. Calculate the mean. In this example, we can start by finding the mean as shown below. So we will end up with a figure of approximately 6.64. 2. Calculate the median. The median is the middle value when the numbers are arranged in order. In this case, the median is 7. 3. Calculate the standard deviation. Once we have the mean and the median, the third variable that is needed is the standard deviation. The formulae below will help in finding the standard deviation. Calculate skewness. Now, with the mean, median, and the standard deviation, we will substitute the Pearson's first coefficient of skewness formula with the respective figures we got. After calculating the standard deviation, you would substitute it into the skewness formula to find the skewness value. Commenting on the skewness of a dataset. Once you have calculated the skewness, commenting on it involves interpreting the value you obtained. Skewness 0 indicates a right-skewed distribution. For instance, if your skewness value is 1.2, you would comment that the dataset is positively skewed, suggesting that there are few high values that are pulling the mean to the right. Skewness 0 indicates a left-skewed distribution. If the skewness value is minus 0.8, you might note that the dataset is negatively skewed, indicating that lower values are affecting the mean more than the higher values. Skewness 0 suggests a symmetrical distribution. If your skewness is close to 0, you would conclude that the dataset is approximately normally distributed, which is ideal for many statistical analyses. Practical applications of skewness. Understanding skewness is essential in various fields, including finance, healthcare, and social sciences. For instance, in finance, positively skewed returns may indicate that there are few extreme gains, while negatively skewed returns might suggest potential losses. In healthcare, skewness in patient wait times can help hospitals optimize their operations. Summatively, by understanding the concept of skewness, calculating it, and interpreting the results, you can glean important insights about the nature of your data. Whether you are analyzing test scores, financial data, or any other dataset, recognizing skewness helps in making informed decisions based on statistical analysis. For further reading on skewness and its applications, you may refer to the following scholarly sources. Understanding skewness. Skewness in data analysis. Statistical distributions and their applications.